Unit 8, Lesson 3, the Pythagorean Relationship. A right triangle has two legs that form the right angle. The third side opposite the right angle is called hypotenuse. So let's see what the meaning of that. As you can see, this triangle is a right triangle. So we can see it right away from this angle that it's 90 degrees. So it's right angle. And because this is right angle, the side opposite to this angle, we call it hypotenuse. So I'm going to write it in red. So this is the first thing, the side opposite to the 90 degree, we call it hypotenuse. What about the other side, this side and this side? Because they are opposite to something less than 90 degree, in this case we're going to call it leg 1 and leg 2. So here I'm going to change the color to black, and I see leg 1, and here in the other one leg 2, and we're gonna change it to black again. So it's clear that the side opposite to the 90 degree, we call it hypotenuse, and the other two sides that they are forming the right angle, we call it leg 1 and leg 2. We go back and we see what we have as note. The three sides of a right triangle form a relationship known as Pythagorean theorem. That means what? I cannot use a Pythagorean theorem if I don't have a right triangle. So it's very important. If you have any type of triangle that it's not a right triangle, we cannot use a Pythagorean theorem. So let's see that Pythagorean theorem is saying what? The area on the square on the hypotenuse is equal to the sum of the areas of the square on the legs. That means leg 1 and leg 2. So let's understand this one. As you can see this drawing, it has three sides. So let's start first to find where is the right angle. As you can see, this is the right angle. So that means this side it's the hypotenuse, this is leg 1, this is leg 2. If you see here, I'm gonna mark with different color the dimension of each leg. Can you see this leg? 1, 2, 3 units. This leg 1, 2, 3 and 4 units. Now if I ask you about this leg, we cannot count the unit because as you can see it's diagonal. If it's horizontal or vertical we can, but in this case we cannot. But with Pythagorean theory we can discover something very important. It's saying that the sum of the area of the square that it's formed by the hypotenuse equal the sum of the area on leg 1 and the area of the square on leg 2. What is the meaning of that? Let's say now I'm going to create a square with, let's say, blue color. I need to create a square on leg 1, so 3 by 3, and I need to create another square on leg 2, 4 by 4, as you can see. Now what about if I create a square formed by the hypotenuse? I don't know the dimension, but I'm gonna try to do something like that, and I'm gonna rotate it till it's gonna match exactly on the hypotenuse. Can you see? I'm trying to match it exactly with the hypotenuse because I don't know the dimension, so I'm trying to do my best to make it on the hypotenuse. It's gonna take some time till I adjust it, and now I'm trying to do it with this way. Here we go. Now it's saying what? Let's calculate the area of the square on any leg. So I'm gonna create it with red. The area of this square 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. This is coming from where? This is coming from 3 times 3, because the area of the square equals side times side. So that means this is equal to 9. 9 unit square. What about this one? Again, 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. That means 4 by 4 equal 16 unit square. If I take the 9 unit square, I add it to 16 unit square, it will give me 25 unit square. Without calculating this one, it's gonna give me 25 unit square. This is the Pythagorean theory. Because I have a right triangle, we are saying that the square on the hypotenuse, the area of it, equal to the sum of the area on leg 1 and leg 2. So I got it from here, the 25. That means I can find now the length of this side. If the area here equals side times side equal 25. One side equal to what? This is exactly like if I take the square root of 25. The square root of 25, that means I'm asking myself, what is the number that you multiplied by itself and it give you 25? We have 5. That means this side equals to 5, this side equal to 5, this side equal to 5, and this side equal to 5. So from here, I know leg 1 and leg 2, they have 3 and 4. I didn't know the hypotenuse, but with Pythagorean theory, I can find it. Let's now start some problems and see how we can use a Pythagorean theory to find unknown lengths of leg or hypotenuse. So if I go to this problem, it's saying what? Find the lengths of the unmarked side in the given triangle. So let's see how we can do this one. Let's figure out which side it's unmarked. First of all, ABC, it's right triangle. This is very important. That means I can apply the Pythagorean theorem. Second, I have 3 sides. The one opposite to the right angle is 13. That means we call this one hypotenuse. So I'm gonna call it like H. The other two that they are forming the right angle, I can say it leg 1 and leg 2. As you can see, I am missing leg 2. So let's find it. Now, what Pythagorean theory is saying? Since H square equal leg 1 square plus leg 2 square, now I'm gonna substitute each letter by its number. H equals 13, that means 13 square, equal. Leg 1, I know it's 5, that means 5 square, plus leg 2, it's unknown square. Someone will tell me, from where did you get this equation, number 1? This equation is Pythagorean theory. Again, we said the square or the area of the square on the hypotenuse, which means 13 by 13, equal to the sum of the area on leg 1 and leg 2. So the square on leg 1 is 5 by 5. On leg 2, we don't know it. That's why we leave it as it is. So what do I need to do now? I need to isolate leg 2 to find the value of leg 2. So to isolate it, let's find the 13 square, the 5 square, and so on. So 169, this is the square root, this is the square of 13. 25 is the square of 5 plus leg 2 square. Now I need to isolate the leg 2 square, so I'm gonna use the inverse strategy. The inverse strategy means what? I need to isolate leg 2, so I'm gonna remove 25 from here. Whatever I'm doing to the right side, I have to do it in the left side. That means I will go and saying I'm gonna add negative 25 to the left side. So 25 with negative and positive, it's gonna be like 0 pair. So now I can go back to the blue and I say leg 2 square equal 169 minus 25. So let's do it. 9 minus 5 equal 4, 6 minus 2 equal 4, and the 100. So 144, which means if I need leg 2 only, I have to square root the 144. So that means leg 2 equal 12. That means the missing one equal 12 units or 12 centimeter, whatever I have, or 12 even meter. It depends on the problem. This is how I can find a missing length. Let's see another one, another problem. It's saying find the length of the unmarked side in the given triangle. As you can see, this triangle, it's A, C, B, and there is a height B, D. Now, if I see to this triangle, I will notice that A, B, it's unknown. So I'm gonna call this side X, let's say. Now, I have X, I have 7. I know this is 90 degree. That means this triangle, the blue one, it's a right triangle. That means I can apply Pythagorean theorem. But I have a small problem. Leg 1, AD, it's known. Hypotenuse, it's unknown. And BD, which is leg 2, it's unknown. 2 unknown, it's difficult for me to find it. So I have to find another way. So in this case, I need to check if there is something to help me. If I check here, I will find there is another red triangle from the other side. This red triangle, again, it's a right triangle. It has leg 1 known, leg 2 unknown, hypotenuse known. That means I can find this BD, and when I find BD and I have AD, I can find X. So I'm gonna call BD, let's say, Y. So let's see now how can I solve this problem with Pythagorean theory. The most important part that I have right triangle. That's why I can apply Pythagorean theory. So I'm gonna say again, since in triangle BDC we have hypotenuse square equal leg 1 square plus leg 2 square. As you notice, I have to write that in each triangle that I'm applying Pythagorean theorem. So I have to apply the theorem first. So since hypotenuse square equal leg 1 square plus leg 2 square, in triangle BDC, what can I do? The hypotenuse is the one opposite to the 90 degree. That means 5 square equal leg 1, let's say the 3. So 3 square plus the other one, it's BD. BD is unknown and we call it Y square. So let's find Y square. Again, that means 25 equal 9 plus Y square. So to complete this one, I need to use the inverse strategy, which means I can isolate Y by saying minus 9. And from the other side, I have to do the same thing, minus 9. 9 with minus 9, this is 0 pair, so I isolated completely the Y. So I can say Y square equal 25 minus 9, which is 16. That means Y equal square root of 16, which means 4. So the Y is 4 and it's known now, which is good. Now I can continue with something else. I can say let's find now X. So again, I'm gonna change the color. I'm gonna say in triangle ABD, what do I have? I'm gonna again apply the same Pythagorean theory. since hypotenuse square equal leg 1 square plus leg 2 square. So that means the hypotenuse here is x square equal 7 square, which is leg 1, plus leg 2 that I found it from here, which is 4 square. So let's continue. X square equal 49 plus 16, which means 9 and 6 equal 15. I have 1, that means 65. So in this case I can use the calculator, and I'm going to say 65, the square root is 8.06. So I can say, I forgot here to say, this is x square equals 65. That means x equal square root of 65. That means x equal 8 point, let's say 1 unit. It depends. Now there is something very important to notice. In these two triangles, you will notice something very important. When I found y, we found it equal to 4. If you compare leg 1 and leg 2 and hypotenuse, the hypotenuse is the largest number. So 5 is greater than 4, 5 is greater than 3. That means my calculation as y, it was correct. Again, let's see in this triangle. I have y 4, I have leg 2 7, x I found it, it's 8.1. 8.1 is larger than 7, 8.1 is larger than 4, that means my work is correct. Let's go back to number 13. We had to find leg 2. We have 5, we have 12, we have 13. Let's check the hypotenuse. 13 is larger than 12, 13 is larger than 5. That means I'm doing good job. So don't forget, as a verification, the hypotenuse has to be larger than leg 1 and leg 2. So I hope you understood this lesson, and the next one is going to be lesson 4. Thank you.